Hello, everyone. This is Pablo Linares with HTIGlobal. I'm the CEO and founder of HTIGlobal. Today, we're going to be explaining the Bell 412 fuel system. And before we move forward with the class, let me talk a little bit about my business. Right here, you can see my point of contact on my webpage. Feel free to look over. And if you have any question or request for training, just send me an email. I'm more than happy to help you. We are a small company based in Texas, and we have been trained mechanics or engineer in 5 continents, and we just passed the 556 mechanics or engineers trained around the world. My business was created in 2014 and became an LLC in 2016. At this moment, we have over 45 FAA acceptance courses. And very short, we have on the Bell line, we're going to have all these helicopters, Bell 212, 206, 412, 429, 407, and 505. On those helicopters, we're going to have field maintenance, recurring courses. Even we have overhaul courses. And even on the 412, we have electrical maintenance courses. On the Airbus line, we're going to have the BK-117, the H350, 130, 135, 145, even the latest and greatest, the D3, and also a very old helicopter, the the Airbus BO-105. On engine side, we're going to have level 1 courses, Pratt & Whitney Twin Pack, LTS 101. We're going to have the Safran engines. And if you can see on this slide, we even offer Leonardo 139 courses and our new line, fixed wings, which is the Cessna 208 Caravan. And also we have the hydraulic servo for the 205, 212, and 412 courses. Now, start now into the course, which is going to be the Bell 412 fuel system. We're going to separate it in 2. We are not going to be discussing anything on the original 412. We call the 412 basic. That one only had 5 cells. We're going to be focusing mainly on the 412 SP, HP, EP, EPI, which are the one with 10 cells. Is the one that have more electronics. It's kind of an automatic system. And that's the one I'm going to be focusing this course today. The references I use for this course are going to be the maintenance manual by Bell Helicopter using the ATA system for chapters. And we're going to use the chapter 28, 95, and 96. Now, the 412 with the 10 cells, they're going to have a capacity of 330.5 gallons. Now, this system, it comes already from factory. If you look at it here, you're going to have these 2 connection for aux tanks. So you're going to have the option to purchase different types of kits from the helicopter where you can expand the range of your 412. Before we get into details of the course, I like to show you here, this is pretty much the whole fuel system. And all these 6 cells we got here are the one located right under the floor of the main cabin. And these 4 cells are located right under the engine deck. If you can see, the whole fuel system cover pretty much the whole for the fuselage, the 412. So when we're going to start talking about the burning sequence and all that, the key point of all this is to control the CG. And that's why Bell Helicopter have to add more equipment on it to make sure that the way burn is adequate and controlling the CG. We're going to have here the forward cells, and the one inside is called mid cells. The one back here are called the main cells. And one of the things important to know about Bell Helicopter, when they say main cells, are the one where you're going to be locating the boost pumps, and also during the sequence are the last one to be emptied. These 4 cells are going to be mounted under, like I said before, under the engine deck, and they're going to have more equipment there that we're going to be talking in detail. Now, all these cells are made crash worthy. The reason for it, in case the helicopter crash, you want to make sure that the bladders or the cell by cell are not going to be shattered, causing fuel leaks. On top of that, in the front, this is kind of in the pedestal between the main cabin and the cockpit right here, you're going to have this air to fuel valve. And the reason for this valve are in case the helicopter roll over, you are not going to drain fuel outboard. So those two valves are there in order to prevent for fuel leaks in case the helicopter roll over in an accident. One other thing I like to train when I'm doing the training is to try to show the interrelationship between the switches and where it's located, where you're energizing, closing, and open in the helicopter. The first ones are going to be the fuel valve, also known the shut-off valve. These two switches located on the pedestal between the pilot and co-pilot are going to be energizing this valve located on the pylon area. These valves are going to be energized with 28 volts DC, and every time the pilot turns this valve on, few things going to happen. One of the things in the order, it's going to happen, not in this order, can happen at the same time. First one is going to be de-energize the drain valve. The second one is going to be activating the PG heater. This PG heater is part of the engines, and that part of the line is right by the compressor. So what happens is you want to make sure that that air going through that section of the engine, due to the low pressure, you're never going to get frozen. You don't want to build ice inside the line, and that's why you got this PG heater. The next one going to be the energize the igniter box. In a way, it is how, in order to start the engine, you need to have fuel, and that's why they interrelate the fuel with starting the engine. That's why every time you need to start engine, you have to make sure the shut-off valve is open. And of course, when you turn it on, you're gonna open the valve. The next set of switches we're gonna have are the transfer pumps. The transfer pumps are located on the forward cells. I was already telling you earlier, those are gonna be located under the floor of the main cabin. And of course, those switches, they're gonna be only turning the transfer pumps on and off. It's important for let you know that when the pilot is going to take off, all the switches are going to be set up forward. One of the good things about the system for the pilot is a fully automatically. Now for maintenance side, it's a kind of challenge because there's a lot of sensors and a lot of equipment that is going to create effect on what to do, where to open, what to close. So it's very challenge system, and all my recurring courses I have to explain or refresh this section of the helicopter, which is the fuel system. The next set of switches are going to be the boost pump switches. They are located also right here, and these are the ones that are going to be energizing the boost pump. These two boost pumps are responsible to bring the fuel into the engines and keep the line pressurized. Okay, you're going to have one for the left side and one for the right side. We're going to see that later on. The next one, we're going to have a valve that's called the interconnect valve. This valve have a kind of a confusion process, and I have a slide that's going to explain better this part of it. But right now, generically, this valve have three switches. A normal position is the one you're going to keep it on when you're going to fly. And then we're going to have some thermistors. Thermistors is it's like a switch, but it's still being on and off by manually. It's by temperature. So as a principle, when those thermistors are wet or inside, they are with the fuel levels above those thermistors, you can say they are on, and then when it's dry, it's going to be off. So this on and off switched by temperature is going to create a logic in the system and do different things. We're going to see also in another slide specifically how that works. But in this case, the switch is located on the cargo compartment hook area, and also it's in the lower section of the pylon. And this valve is going to have normal position, open position, and override closed position. And I'm going to explain this later when we start involving electrical switches and thermistors later. Right now, I just want to explain you the location and the function of the valve. Then we're going to have a crossfeed. The reason for the crossfeed is in any case one of the boost pump fail, this valve is going to open, so one boost pump can pressurize both engine fuel lines. So this is pretty straightforward system, and it's going to be activated by another device which is called the pressure switches. I'm going to explain that in a diagram later. Looking at this picture, you can see a lot of stuff. What I'm trying to do on this slide, trying to bring real picture of the location of the different component of the fuel system. The 412 is going to have one filling port. It's going to be located on the right side, and that port is going to be located on the upper right fuel cell. And as you can see here, the openings for fueling the helicopter. Now, if you look at here, we're changing the color. Remember, right now I'm explaining one side, so everything I want to explain it in here is going to be the same on the other side. Right now, for the purpose of the class, I'm going to be talking only about the left side of the fuel system. The first part we're going to find on the main cell, we're going to find the boost pump assembly. And right there, this one is called the flow switch check valve. This have an important function on the logic to turn the transfer pump off. And I explain that later. Right now, we're trying to get more general information before we get into detail of the system. Then we're going to have the ejector pumps. The ejector pumps are going to be located on the mid cells. And again, you're going to have one on the left, one on the right. Just for the presentation, I'm showing only one side. And this ejector pump has an upgrade. That's a bulletin bell made, and that's you can see it right there. This is a check valve, and what happened is many years back, I think over 25 years ago, they have some issues. They have what called a reflux. When we start flying the helicopter, many things are going to happen. Even the sequence of burning the fuel, you're going to have to a point that the mid cells and forward cell are going to be empty. During that time, if you have a reflux of fuel going back to the mid cells, that fuel is going to be trapped. So that's kind of dangerous because now you're limiting your range of the helicopter. If you fly offshore, that can cause a very bad situation where you can run out of fuel before you reach to your platform. So Bell all the time try to improve the system, and this is a very good option, and that is a technical bulletin where you have to change the ejector pump, in which is going to include this check valve. Then we're going to have the forward cells. In the forward cell is where we're going to have the transfer pump. The transfer pumps, again, we're only showing one, but you're going to have also on the other side. So we're going to have pretty much 2 transfer pumps and 2 boost pumps, and also 2 ejector pumps. These transfer pumps, as well as the boost pump, they are energized with 28 volts DC, and these are what we call a positive displacement. This pump, when you turn it on, is going to supply all the pressure and flow of fuel they can. There's no control. It's just on and off. Also, on the upper left and right, we're going to have the long probes. In the bottom, we're going to have a thermistor. We're going to see that later on when we start talking about more components that we're going to find on all the cells. The way we sense, or the pilot can see the fuel pressure going into the engines, is through these 2 transmitters or transducers, depending of your Bell 412 models. Those transducers or transmitters are mounted on the firewall between the main cabin and the engine compartment. We're going to have the 2 pipes. These 2 pipes are going to be installed on the forward upper cell. We're going to see that in other pictures. And the good thing about these pipes are, if you look at it here, look at the height of this one and that one. So all this is going to be helping on creating the different sequence of the fuel burning. So that's the way we're going to see later how we burn the fuel. It's not going to be like you think going to go down all the way now. No, it's going to be burning one side, then forward, then back, and then further forward. So again, we're trying to control the CG while you fly. The cartridges, we're going to have 4 cartridges, same part number. 2 are going to be for the transfer pump, and 2 are going to be for the boost pump. They can be replaced even with full of fuel. There's a process in the books. And also I have another slide where I want to explain a little bit more the important you have to be, you have to have some cautious when you remove it and install it. Venting, we're going to have venting everywhere. The only reason I put this one here, this is for the main cells. This vent with times is known to leak. It's kind of awkward. It starts leaking when you're full of fuel. When you lower the amount of fuel in the helicopter, stop leaking. That well, you're going to have a big well here. You're going to have a hole there for drainage. So one of the problem is that it only leaks when you got a full of fuel. It's building more pressure, it leaks. And sometimes when you lower the amount of fuel, stop leaking. So that would be a good option where to go when you have this kind of issues in the helicopter. Now, from here on, I'm trying to isolate different components while we still building the fuel system. Again, the fuel system on the 412 is overwhelmed. You have a lot of devices, and of course, it brings a lot of issues for maintenance on the helicopter. The first one, we're going to have the fuel cells. The right forward fuel cell have a special shape, and because here is where you got the pedal push-pull tubes going through, so the shape is different. Then we're going to have the mid cells, and then we're going to have the main cells. Okay. Now, after you go on the main cells, we're going to have more cells that are going to be mounted in the different location. I already explained to you that all these 6 are going to be mounted under the floor on the main cells, and these 4 are mounted below the engine deck. And again, for nomenclature of the upper one, you're going to have the upper center, upper aft, upper right, upper left. So all these 4 cells are going to be mounted in the back, right below the engines. Then we're going to have something very interesting, isolation barrier. I'm not exactly the specifics, but I think is a 9,000 pounds or 9 passenger. Anytime you have an aircraft that big, by regulation, in order to have a type certificate on the helicopter, you have to have 2 independent fuel systems where you have a low amount of fuel. In this particular case, this isolation barrier is dividing both systems completely independent. So if one side is leaking for anything, the pilot have the authority to isolate it. He's gonna override and close the intercom. So he have only one side pumping fuel to both engines. That's why it's important and this is part of the requirement to have a type certificate. The pipes, the 2 pipes I mentioned to you are going to be mounted on the forward upper cells. You can see it here. We're going to see how you install them later on the fuel system. The filling port is located right here. It's going to be on the right side of the helicopter, most specifically on the upper right cell. What component do we have on each cell? It goes as goes. We're going to have a 4 quantity probe per size. So a total probe we're going to have is 8. Now, if you are flying, if the pilot's flying, he's not touching anything, these 4 probes are going to give you this analog indication, and this 4 is going to give you this side analog indication. By itself, this is going to give you the total amount of fuel in the helicopter. And if you look at it, it's only 3 digits, and here tell you time 10. So if you have a 010, you need to add another 0, going to be 100 pounds. Or if you got 120, 120, going to be 1,200 pounds of fuel. Also, back in the day, they have some issues where the pilot, and you can keep doing it, you can check the probe on the forward, on the mid cells. So if I press the mid cells, only this one and that one are going to give indication, again, analog, and the total amount in there. And that's why you have this indication. You're going to have a total of 5 indication on the fuel gauge, okay? These probes are known to short it out sometimes, and you have to be careful how you troubleshoot it. Later on, you're going to see a slide that I explain about the DC400 bar fill device. Now we're going to talk about the famous thermistor I was telling you about. The thermistor, again, is like a switch on and off, but here's by temperature. So when they are when the level of fuel is above, so they are under the fuel, it's going to have a different temperature when they are dry. Now, it's important that later we're going to start seeing the function. All these 4 thermistors located on the forward and mid cell is going to have a function very different than the function we have in the upper left and right. So we're going to have a total of 6 thermistors. The way they work are the same, but they have different functionality in the fuel system. The next, we're going to have 4 mechanical drain valves. They are located on the forward and also on the mid cell. The only ones electrical drain valves are going to be mounted on the main cells. And I already explained a little bit about this. Every time, remember, we talk about the shut-off valve or the fuel valve. So when the pilot turns those valves on, you don't want to have any power to drain fuel. And the reason for it, you want to make sure that this solenoid, when you fly for no condition, you're never going to be able to energize and start draining fuel. So like a fail-safe mechanism. So every time those fuel valves are on, there will be not fuel. You cannot drain any fuel from the solenoid. Lastly would be the fuel valve. The fuel valve is like a cap. Inside there, you have like a kind of a quick disconnect where you connect it. Ironically, in the field, nobody drain fuel from there. Most of the people, they take the line, goes to the fuel counter unit, and from there is where you're going to drain the fuel. You put an extension line and into the fuel truck or whatever the device you have to collect the fuel. And that's pretty much the most common. Of course, everybody use an APU. You don't want to use the battery of the helicopter. You use an APU. You follow the safety measure, ground the helicopter, and so forth, and you drain it from there. Very rare, I've seen people draining fuel from this valve. Anyways, if you follow the manual, just follow if you think is the safety way for your operation, and follow the Bell Helicopter manuals, okay? The fuel pumps, we're going to have, remember, we have a different pumps. So this one are the transfer pumps. They are located on the forward cells. And we're going to have the ejector pumps. The ejector pumps is in reality is a Venturi, and they need something else to make them work. On this particular case, the transfer pump are the one that are going to make the ejector pump to work. The other 2 set of boost pumps, the electrical pump we're going to have are the boost pump located on the main cells. As you can see here, this is the boost pump, this is the transfer pump, and this is the ejector pump. The supply system is a set of lines we're going to have all over the places of the helicopter where they're going to be interconnected in one way or another. And these lines are going to be located under the cells. Like these 4 on the bottom, you're going to have connection. Also, you're going to have some connection on the side. And right here, we can start seeing the pipes. Now, if you look at it, we're going to have this line will go all the way to the forward cells, and this pipe is going, the line is going to go to the mid cells. Now, it's important to point it out that between the left and right, there is no controller of it. So in a way, you're trying to equalize the level of fuel from left and right. Same thing on the mid cells. In the mid cells, there's no valve in them. The only one we're going to see later are going to be between the main cells. That's called the interconnect. But right now, for the supply, it's not affecting us on this section. Venting is another of the most important system. I help people to troubleshoot the system. One of the problems with the venting is you have to remember, when you are burning fuel, even you are on the ground, you're burning fuel. Every time you take fuel from the bladders, you have to put air on it. If you have a clogged line, a venting line, you can create a vacuum, create a resistance, and that can cause you a lot of problems. So it's very important to pay attention and inspect your venting lines. You're going to have a total of 3 independent systems. The forward right is going to be for the forward cell, and the mid cell on the right, same thing on the left, and the back is going to collect a lot of ventilation from the main cells and all 4 with 2 port outboard. So that's kind of pretty much the venting system on the 412 with 10 cells. Now, we start talking about now how you're transferring the fuel. What is the function of this? We're going to have, again, the 2 transfer pump pumping fuel through the ejector pump back into the upper center bladder or cell where you have the pipes. And very interesting, if you look at the transfer pump, you're going to have about 1,270 pounds per hour, and the pressure is kind of low, around 7 psi. Right after you go through the ejector pump, look at the flow. You're going to have 2,540 pounds per hour, and the PSI is very low, 1.7. Really, what we're trying to do is moving a lot of quantity of fuel. We don't care about the pressure. You're trying to move fuel around. And what is that? Because when you're moving fuel from one side to another, you can control how or which side is going to burn first. And we're going to see that later. I hope you are understanding what I'm talking about right now. And all of the thing, if you can see the transfer pump where you suck the fuel from here, go to the ejector pump suck the fuel from the mid cell, and then it's going to be going all the way to the upper cells. Okay. Now the pressure side means is there from the boost pump going all the way to the engine. Now right here on purpose, I cut it off from here down, which we're going to be up, of course, in the helicopter. This is schematic. Right here, stop what is airframe. From here on, it's going to be engine side of it. So we're going to have two boost pumps. And one thing I like to explain on this slide is the function of this check valve. The primary function of the check valve is if one of the boost pump fail, we're going to have a switch. We're going to see that later. And this is the crossfeed. So if one pump fell, let's make an example. The left side fell. This one is still working, but this switch we're going to have here is going to open the crossfeed. So this boost pump is going to pressurize his own engine, going to go through here to pressurize the other engine. But because this pump failed, you don't want to bring that fuel back into this system. So that's why you're isolating the check valve. On top of that, this valve have an orifice in the center, and that's for the thermal part. I'll explain that later. Now, this is what I was telling you. Right here, the fuel heater are being mounted on the engines. Pretty much it's on the engine. The only part is on the airframe. It's going to be this switches. I'm going to explain that later. Here we can see now the fuel valve or the shut-off valve we talked about earlier. This is the crossfeed. And we're going to be moving on where we're going to talk about more, start getting into the electrical part and indication. And right now we can see the caution panel mounted on the cockpit, and we're going to see a lot of stuff going on. This part we already talked about, and here come the first electrical indication, going to be the transfer pump. So for 1 second, you start taking out your full of fuel, and one of the transfer pump fail. As soon as one of the transfer pump fail, this flow switch is like a gate type. So when you have no flow of fuel, it starts closing. You have a micro switch, and this micro switch is going to give you the indication. But there's more into it that I explained in another slide because the logic. For this light to stay on, you're going to have a thermistor in the mid cell and a thermistor also on the forward cell. If those two thermistors are wet, meaning are under the fuel, that means reality is a transfer pump failing. But here's the problem. This light can also misleading you. And you can see that when you're on the ground. For 1 second, imagine you're full of fuel and you're about to take off, and the pilot call you, hey, I got the light on it. The light is on and you're full of fuel, but you can hear the transfer pump running. So if the transfer pump is running, but the light is on, most probably it's because the micro switch is shorted out. And so what you have to do, you have to replace the flow switch assembly where you have the micro switch, because giving you a false indication. Now, the next one set of indication going to be here, the pressure switches for the boost pump. These switches are going to be sensing when your pressure go below 4.5, that light's going to be on the cockpit. Okay, but also going to happen something else. I was mentioned to you that these switches are going to be connected to the crossfeed. So whichever pump fail is going to open the crossfeed. And also the light's going to be extinguished when your pressure go above 8 psi. Even though your range is from 4 to 35 psi, pretty much your range is between 12 and 15 psi normally. Now here we can see a lot of lighting. You can see all the stuff. And this is the part was mentioned to you. See if either a boost pump fail, it's going to be wired into the crossfeed. So the valve is going to open automatically. The pilot have the authority to override and close. Okay. Now, if you can see the fuel crossfeed valve lighting on, the same thing is going to happen with the fuel valve and the interconnect. So what does that mean on the lighting? The lighting is going to happen when the valve are in transition. And so whichever pilot does, if you're going to open and close it, the valve is going to be illuminated on the caution panel when it's in transition. Why is that? For instance, if the pilot want to close a valve and the light stay on, it means that the valve didn't go the full travel. That means for the pilot, the valve is not fully closed, or vice versa. So this valve have a way to give an indication only when in transition, and that's normal procedure to the light be on when you apply power to this valve. And this is what I was explaining you, fuel valve lighting. When does that happen? Only when it's in transition. Fuel filter. The fuel filter back here is going to be due to a differential switch that when you have about 1.4 psid, that switch is going to give us a light, meaning the fuel filter. But here's come another troubleshooting. If that light you see there and the pilot report it and you want go to the helicopter and you replace the filter and that light continue, most probably will be the fuel heater. If you look at it, the line before the fuel heater is going to the switch and then after the filter. So whatever is in between them, that's going to give you an indication for the light. So most probably if you change the filter and the light continue on, most probably is the fuel heater. Now, here comes some of the logic. If you look at, go back, when I turn this one is, you're going to see the thermistor located on the upper left and right bladder cells. Now, whichever of the thermistors are above the fuel, meaning you're letting the fuel is lower than the thermistor, whichever left or right, you're going to have the indication of fuel low light. Okay, so whichever, and it's about 190 pounds of fuel. There is not way you can say how much time it is. It's prohibited. You probably have to do some own calculation. If somebody comes to you, okay, 190 pounds, how much time do I have? Only 198 pounds. And my advice, don't give information about time, how much time you have it. Only quantity is a decision the pilot have to take on his own regarding when he have to land if you have a low fuel light. Okay. Now, here's come the other one. Now, I was mentioning to you only with one thermistor is dry. Now, if you have both thermistor dry, meaning the fuel is below their thermistor, that is a logic where the system, remember, the switch or the interconnect is open in normal position. It's going to be closed. The system is going to open the valve. So because this is done by the system and not by the pilot, the valve is going to open and the light is going to stay on. This is what we call it disagreement light. Disagreement light because the valve is in one position and the valve is another. So what the pilot have to do, he need to bring the switch into the open position, which is already done. So at this moment, the light is going to extinguish. Also, the pilot have the authority to go back and override and close it. So it's very important about this light. In other words, to say this, when the system open the valve, the system is telling the pilot, hey, I open a valve. Do you want to keep it open? He got the switch and put it in the open position and the light extinguished. Or if he prefer override it close, he can do that and the light continue to be extinguished. Why? Because the switch is in the same position as the valve. That's how we call it the disagreement light. Now, from now on, we're going to be talking about how you fill the helicopter and how you burn the sequence of the fuel in the helicopter. Now, here is the picture looking from the top. And here is looking the fuel system from the side. So I hope you can see both systems. This is kind of small as a reference. And I try to do my best. When you start pumping fuel into the fuel system, the first one you're going to fill up is going to be the main cells. And of course, when it's full, you start filling up this section here. How do you know it stopped there? Is because the short pipe right there stopped. From this moment on, you keep pumping fuel, but that fuel is going to go directed through this pipe into the forward cells. So that will be the next one. After you top it off, there's no more fuel. Then from here to here is another section, which is the difference between the short and tall pipe. When you get to this one, now you start feeding fuel into the mid cells. And finally, the last section before you start getting to the border lower section of the filling port of the fuel system. And that's pretty much how you fill it out. This system takes some time to top it off. So give it and take 15 minutes, 20 minutes. It's a slow process to fill them up completely. Now, the next slide is like, I imagine you are full of fuel and you're going to take off. On this particular case, what we're going to do is we're going to crank the engine. Remember, when you got everything running, only the boost pump are the one taking fuel from the whole system, taking on the engine, and the engine is going to burn it. So everything else going on in the system is moving fuel from one side to another to control, again, CG. So let's crank it off the engine. We're going to run everything. And the first part we're going to be doing, we're going to burn the upper part. That one is where it's going to be between the lower section of the filling port to the edge of the top pipe. Right here, there's no more feeding fuel into the mid cells. So on this particular case, you keep flying. Remember, everything we're doing right now, both engines are running, you're flying the helicopter, we keep burning fuel, and we're going to extinguish, or we're going to empty the mid cell. When you're doing this, the transfer pump is still working. Everything is working. Why? Because if you look at the lower pipe are still full of fuel, still managing fuel. So in this particular case, whatever fuel you got on the transfer pump is going to go back in here. It's like a fountain. You go back again. You're creating a flow of fuel from one side to another. After you got to this point, now the difference between the tall and short pipe, you're going to use that fuel. And when you get to this point, now we are not feeding any more fuel to the forward cells, and that will be using it. Right on this particular moment, by the way, pilot doesn't have to do anything. When you get to this situation, the flow switch is going to close. But this is something very interesting happen. When this happens, both thermistors on the forward and the mid cell are going to be dry. So what happened is, this situation is a logic. So what happened in 30 seconds, the system, you're going to shut the transfer pump off automatically. The pilot doesn't have to turn off the switch. Everything is still on. Is the whole system is going to be doing this. This happened around 900 to 830 pounds. And of course, the caution light is going to flicker, and the transfer pump is going to be on and off very quickly. It's nothing wrong. It's part of the system. Finally, we're going to have whatever's left on the upper cells. And this section here, number 5, is where you're going to have the thermistors in the bottom for low fuel light or to open or the interconnect valve. Right here is when you're going to happen. And finally, with the last one we're going to empty is going to be the main cells. Continue. We're going to have I can say the part that people come to me on the recurrent courses about the logic, how the system works. And here it is. We're going to have the cushion panel. We're going to have here the transfer pump. Again, I'm doing only one side. Okay, so it's not to everything that happened on the left can happen on the right. It's exactly the same system. One of the devices we're going to have on the front are going to be the signal conditioner, and you're going to have two, one for the left and one for the right. They are not interconnected, but they are, you can say they are the brain of the fuel system. And this is something I did to give you a better view of what's going on the logic. Remember, we are going to be talking only on the thermistor located on the forward, on the mid cell. The one back here on the upper left and right has nothing to do with this. Remember, the upper left and right has to do only with low light, low fuel light, and also the interconnect. So let's start flying the helicopter. We're going to be burning the fuel here. Then we're going to burn this one. At this moment, the thermistor of the transfer of the mid cells are empty, are dry. We continue flying the helicopter. Now, when we get to this point, right here, now the transfer pump is sucking air and fuel. What happened with the flow switch? The gate start closing, and you're gonna close the micro switch. When that happens, it's going to give you a signal, hey, the transfer pump is not working. Remember, this happened very fast. I tried to explain it. I cannot go that quickly, but this is what's going on in the system. As soon as this light on, we need to know if the thermistor on the transfer on the forward cell is dry or wet. If you look at it, we got a signal. Thermistor say, oh, it's dry. Let's do it on the mid cells. Same thing. Now, if you look at it, the logic is telling the system, okay, I'm dry on the forward, I'm dry on the mid cell. What happened next? The system is going to shut the transfer pump. It's about 30 seconds, and the system is a normal operation, and you continue flying. This is what's happening on this system. And I was telling you, imagine for 1 second, you are here on this situation, whichever, on this one too, and the pilot on the ground said, hey, I got the transfer pump on. What's going on? Is bad? Well, not yet. You can hear the pump running. It means maybe the flow switch, micro switch is shorted out. So that means you have to replace it. It's a false indication, okay? Now, why Bell went to the whole trouble for creating a sequence of this is because of this. You see, when you are full of fuel and you are empty, you're moving the CE forward, but you see how you're controlling the CE. So it's pretty good and a very ingenious system where you're going to have fuel right behind the pilot and all the way in the back of the engine. It's a lot of area, but the CE is not affected greatly because the way it's burned the fuel. And you can see it's an example how it's done. Here's the cartridges for the boost pump was mentioned to you. Remember, you can replace them even full of fuel. Be careful. Bell tell you it's a process to install this lever. It's very soft aluminum, so don't force it. You need to press it by hand when you're going to install the hardware. The most important thing is the mark. You see the V mark, this one and that one, and it's because the cartridge by itself and the impeller, they are two disconcentric circles. So the cavity here is not even. So you have to make sure you align the V when you're going to install the cartridge, okay? This is the tool that Parker's sells to you, or you can make one if you, it's up to you. I made my own, but you can have it one bill or buy it through Parker's as well. The same thing we talk about the pressure and everything. When you shut the engine, you have to remember this is part of the engine. From here is part of the engine. So when you shut down, this is the fuel valve. You have to make sure that all this pressure stay there. When you shut down, it's going to get hot. So you want to make sure you are not going to damage anything. And that's why we're going to have this thermal relief valve. And this thermal relief valve, this arrow here is this part. It's like a spring and a ball, a steel ball in there. And what happens is when you build in too much pressure, you're going to go through that orifice. You're going to crack that valve and you're going to bleed it off in this system, controlling the pressure on this area that goes between the fuel valve and the engine itself. Same thing happening here. These two valve or check valve that I talked to you earlier, they are located on the pilot area. So you have to make sure after you shut down, this area is kind of confined and hot. So anytime you shut down, all the building pressure due to the temperature, you want to bleed it off. What happens is you're going to have an orifice. It's about 18,000 of an inch. So when you compress the fuel and the molecule of the fuel go less than 18,000, you're going to bleed off into the system, controlling the pressure in this area. That goes from the check valve to the fuel valve. These are the two valves. And if you look at the new shape, this is the old one. This one is the new one. And it looks outside very similar to the one below the coolers. They have different part number because this one have an orifice, 18,000. And you can see that with a flashlight. And of course, the part number are different. Okay. The switches that I mentioned to you, this is the pylon area. Many people call it the hellhole. And you're going to have the switches for the boost pump. And again, I mentioned to you, these are responsible to open the crossfeed valve as well. Here is the DC400. The DC400 is like a brain. This can really check everything in the fuel system without fuel. It's very advisable. Just remember, when you buy it, you have to buy for the 412, the DC 400. Barfi sell it for different helicopters. So make sure when you buy one, it's specifically for your helicopter. All the Bell 412 bladders are crash-worthy, but they are not. Again, they are not self-sealing. For that, the helicopter have a kit or several instructions they offer, the 68. This system is called the tolerant fuel system. This one is like a 2-layer with a gel. So if you got a bullet or something that puncture the bladder, that mixture between the fuel and a kind of a gel product in there is going to seal the cell and you have no leak. But it's very heavy and it's an option that the customer has. Finally, we're going to have here the location of the main cells. I'm sorry, the forward cells. This is the forward cells. And you can see the push-pull tool for the pedals. And this is the mid cell on the right side. They are located on the main cabin under the floor. Okay. Finally, thank you very much for your time. This is Pablo Linares, and this is my business. I do courses all over the world. You can reach my webpage. This is my email. If you want to take a moment, you can pause the video and you take a picture of this and you can take it to the webpage. I'm more than happy to help you in any way I can. I have also a YouTube channel. Just type in search HTIGlobal. We offer courses in Spanish, in English, in Italian, in Portuguese, and now we can offer also in Bahasa, in Indonesia. We continue listen to the customer. We are here to support anyone. And I would like to take a second to say thank you to the sponsor, the Concord Batteries, for this opportunity to show my courses, a small section of it. This course that I'm telling you, this is only one chapter. The 412 have 17 chapters. So feel free to reach out to me if you need a 212, 412, 205. Again, I'll show you all the courses we have, and I'm more than happy to answer any question you have. Thank you very much. You have a great day. Pablo Linares.